Hi everyone, me and Jinshan gonna introduce the World Happiness Report, and this is all our topic. And in our presentation, we have four parts: introduction, descriptive analysis, and visualization, modeling fitting, and conclusion. So in the first part, introduction, we have also have four parts: project introduction, data description, research question, and data processing. And with the economic development, countries start to pay more attention to people's mental health. So the United Nations conduct an annual World Happiness Report survey, which is to reflect the happiness for people by measuring the various indicator and happiness score of different countries. So we performed a descriptive analysis and visualization on the data on this data set, and also do regression and classification with different algorithm by dependent variable happiness score and happiness level, which is the category variable that we created by the happiness score. And our data is collected from Kaggle, and our raw data has 6 documents, and each document have more than 115 50 different countries in the world. And here's a link of our data. And here's some variable explanation. And our research questions are mainly divided into 3 aspects. By doing descriptive analysis and visualization, we can describe and visualize the data statistically. And also we will do the regression with different modes and compare them to find the best one. It will help us to analyze how other related dependent variables affect a country's happiness score, and also we can use it to predict the happiness score. We will do the classification with different algorithms and compare them to find the best one, and also we can use the best one to do some prediction. And our data processing before everything. So since the survey method of the 2020 World Happiness Report is totally different from before, so we only select the data from the year that from 2015 to 2019 for analysis. And there are some different variable names in this data set among this year. So we keep only 10 common important variable, which are country, region, happiness rank, happiness score, economic, family, healthy, freedom, trust, and generosity. And also we rename the column to maintain the consistency. And finally, we merged this 5-year data from 2015 to 2019. And merge this 5-year data then into one Excel named 15 to 19, and add a new column named year to distinguish the year of the observation. And in our part 2, we have the descriptive analysis and visualization. We have 4 example. So for the 4 examples about happiness region, happiness economic, happiness with family, happiness relationship with the healthy. And happiness with region, we use a tabular to create a map, like a heat map, to show that happiness score among the world. So the happiness score is, if the higher happiness score is will represent as a deep blue, and the lower happiness score will represent as the light blue. So the country with high happiness score are concentrated in Europe, North America, and Oceania. And happiness score of the South America are moderate. And Asians, so overall happiness score is low, and Africa has the lowest happiness score. And in this picture, we can see the map on the left is similar as this one. So it shows the happiness around the world, happiness score around the world, and the map on the left right hand is about family score around the world. So we can, by comparison these two maps, we also can know some relationship and this scatter plot and trend line, we can also see some relationship between these two rivals. So from this picture, we can see that the scatter plot and we can see that there's a positive correlation between these two rivals. And this picture are same. So economic is a score that represents factor that economic factor contribute to the country's happiness score. And from the world distribute plot of these two rival and the scatter plot, we can see that there's a significant positive correlation between these two rival. And this is about a healthy score that represents a healthy factor contribute to the country's happiness score. And similar to above analysis, and there's a very strong correlation between these two rival. And Jinshan Wan gonna introduce the modeling fitting part.
Hello everyone, this is Jinshan Wan, and as mentioned before, in our model fitting part, we have two parts. The first one is a regression, and the next one is a classification. So I will go with the regression first. So at the beginning, next page please. So at the beginning, when we do the regression with different models, the first thing we need to do is to do some data processing. And in this regression part, we select the 6 variables, which are economy, family, health, freedom, trust, and generosity as independent variables. And we select the happiness score as a dependent variable for modeling. So we convert the data type of the year variable into a string and use it as a standard for the stratified sampling. And the sampling method we choose is a k-fold with k equals to 5. So after that, we can get the training data set and the test data set. So after the sampling, we just remove the string variable year because we don't want to use it as an independent variable. So the first model we use is a simple regression tree, and from the output of the NIME, we can see the scatter plot which shows the actual happiness score and the predicting happiness score relationship, and also we can get some like model the indicators of the model, like we mainly focus on some like important indicators like R squared and the MSE. So for this model, the R squared is 0 point is about 0.6, and the MSE is about 0.48. So the next model we choose is a random forest regression. And similar, we can also get the R squared is about 0.8, and the MC is about 0.24. The third model we select is linear regression, so which is a little bit different from the last two. We can also get a table which can show the coefficients of different independent variables and their p-values. So from this table, we can see that all p-values of the independent variables are smaller than 0.05, which means that the all variables in our model is very significant. Also, we can guess the R squared is about 0.76 and the MSE is 0.3. So the last model we use is a polynomial regression, and totally similar. We got R squared and MC, which are 0.76 and 0.29. Last part, we will just compare the different models we select. So usually from this table, we can see the random forest regression is definitely the best model because it has the highest R squared value and the lowest MSE. The effect of linear regression and polynomial regression is pretty close. And among these four models, the simple regression tree has the worst performance. The second part of our model fitting is classification. Also, we choose the four algorithms for this part. And at the beginning, we also do the data processing. we just use same six independent variables in this part, and but we create a new variable named happiness level as a target variable based on the happiness score, and which has three levels of low, medium, and high. So you can see the screenshot on the right side. It shows how we do that in the NIME. And we just keep the number of the observations in the three levels almost the same. And after sampling, we remove the variables year and happiness score. It is because in the classification part, we don't want to use the happiness score as an independent variable. So the first algorithm we choose is a support vector machine, SVM, and for the output of the NIME, we can get the confusion matrix and like the accuracy value. So the classification accuracy of SVM is about 65%. The second algorithm we choose is PNN, and totally similar. We focus on the accuracy, and it's about 73%. The third algorithm we selected the decision tree, and which is a little bit different. We can also get like the decision tree diagram by using the node named decision tree view in NIME, and it does help us to see the classification rules in decision tree more clearly. And the accuracy of the decision tree is about 68%. Last one we choose is logistic regression. Similar, the accuracy of this algorithm is like 72%. Last part, we just compare the four algorithms we choose, and we get some like important points, like the classification accuracy of PN and logistic regression is higher, and they reach more than 70%, and the accuracy of SVM and decision tree is relatively low, but it's still acceptable. So next part is about our conclusion. So there is two parts. First is some conclusion for our modeling, and the next part is to providing some suggestions to the national government. So the conclusion part, if you want to do the regression for predicting the continuous variable happiness score, we're definitely gonna choose the random forest regression, which has the highest R squared value and the lowest MSE. And if you just want to like to predict the happiness level or do a classification, the PN and the logistic regression might be the better choice. Next page, please. So the suggestion part. So the goal of our project is to obtain a model that can predict people's happiness scores with high accuracy, because this can be used by the several governments. Like in the regression part, although the linear regression is not the best model, but it has a multiple linear regression equation, and by analyzing the coefficients and the intercept of the equation, we can easily know that how different independent variables affect the target variable happiness score. So it helps us to make some suggestions to the government, like to help them to make good use of their resources to increase their happiness score. That's all. Thank you.